Video is now on YouTube, but it wasn't until today, so sorry about that. Not as if you're going to go back and watch it. Maybe, maybe. You save that for the weekend, something to do on the weekend instead of a movie night. Okay, so we've got this. Now we're going to talk about functions and applications. So there's really going to be like two major parts today. We're going to first just make sure we all understand what a function is, the notation of a function, how to read or look at a function graphically and read values off the function. And then we're going to do word problems that have to do with functions. That's pretty much today. So let's go back and look at, up to this point, what we've been studying are linear equations. So I'm going to say so far, right, what we've been doing recently is linear equations in two variables. Linear equations in two variables. So something like this, x plus 2y equals 10. And we should all be able to now look at that and be like, oh yeah, if we graph that, that's a line, right? And we have these different methods to graph it. Yes? Okay, well, if we solve this equation for y, right? If we solve for y, we just subtract x on both sides, so we get negative x plus 10. And then we divide both sides by 2, we would get y equals negative 1 over 2x plus 5. Now I'm moving kind of quickly. Do you mind? Thank you. I'm moving kind of quickly here, just kind of reminding you what we can do, right? So move things around, divide, and then we get this form of the line. So today is about functions, all right? So what I want you to understand from this is right now, if you look at this, if I give you a value of x, you can plug it in here and then figure out what y is, right? So with this kind of equation, if you are given x, then you can find y. Right? If you're given x, then you'll be able to find y. When we have this happen, okay, whenever we have this situation where I give you the x and then you can easily just go plug it in and get the y, we say, in this case, we say y is a function of x. Man, this board's squeaky. Y is a function of x. Y can be determined if you give me x, right? Y is a function of x. And whenever that happens, okay, we can change our notation. And instead of writing this, so we can change the notation we have and go from this and switch it over to this new notation, f, and then a little set of parentheses with x in it, and then equals negative 1/2 x plus 5. So all we've done, if you just notice the only difference between those two, is that I have taken the y and I have replaced it with this notation, right? That's all I've done. So this, though, if you look at this now, this is a little more direct in telling you that this side can be determined if I know what x is, right? Somehow this answer, the left side of the equation, depends on x. Give me x, I'll be able to tell you this value. And so we use the letter f to represent function, right? Just f for function. So this is a new notation. It's called functional notation. And we just want to make sure we know how to use it. I know many of you are comfortable with this already. So let's continue with this, all right? What's nice about this notation is that now if I want you to start plugging values of x into this, it's easy for me to tell you to do it. So if I say, using that same example, find Let's do a couple of these. A, find f of 4. Okay, look at that notation. What that notation is saying is, what you're going to do is look at this function over here, right? And you're going to replace that x with what? 4. So we're going to take this expression and replace that x with 4. Okay, and that's it. So I'm going to put equals negative 1/2. And then I replace the x with 4, so I'm going to put 4 here, and then plus 5. And then now you just have to do your correct order of operations, right? And this right here, the negative 1/2 and the 4, this is multiplication. That's addition, so you're going to do these two together first. If you take half of 4, you get 2, but then there's a negative, right? So you'll get negative 2, and then you add the 5, and you should get 3. Okay? So that means if you plug in x is 4, the function will spit out a value of 3. And just keep in mind, the thing that you would be given, right? This is what I would give you. Okay, so on a test or quiz or something, I'd say find this, and then this is the part that you have to do, right? Questions? All right, how about this one? F of 0. That means you're going to put x is 0, right? You're going to replace the x with 0. So negative 1/2 times 0 plus 5. What does that equal? This is going to be 0, right? Right? Half of 1/2 times 0 is 0. But then what? Plus 5, so you get 5. Okay? Let's do one more. Let's do a negative. So how about how about a negative fraction? F of negative 3/5. So I put a fraction there just to make your life miserable. I'm going to do this up here. Okay, so this would be equal to negative 1/2. Then we replace the x with negative 3/5, and then we add 5. All right, so let's see. Who did I not call on last time? Let's see, Keely? Did I call you last time? Where's Keely? Kylie? Is it Kylie? Oh, it is Kai. It has an I before the E. So I called Kylie C. Kylie D? Okay, so how would you do this? Okay, so when you multiply those, what would you get? How do you do it? How do you actually do the multiplication? Okay, so that's division. Remember, if you have division, right? So multiplication, just go straight across, right? So what would you have on top? 3/10. Good, right? 3/10. See, when I call on you, I put you on the spot, you get all nervous. All right, plus 5, right? Yes? Now, see, Ashley, are you here? Yes? Where's Ashley? Ashley, okay, Ashley, how would you do that? 5/1, so you're getting a common denominator? Good. So you're going to go 3/10 plus 5/1. And then how would you do this? I'm just curious. There's a couple of ways. Okay, so you multiply, you're going to make a common denominator, so you multiply top and bottom here by 10, like that? Okay. So you would get 3/10 plus, let's see, 5 times 10 is 50, over 1 times 10 is 10. And now you can add them, right? So what do you get, Ashley? Careful, you're adding. Right, so you just add the numerators, right? 53, and then the denominators stay, right? They stay as a 10. There you go. 53/10. Questions? Sure? So plugging in nice numbers, right? That's like kind of nice, right? But once we get to like fractions, things can get a little messy. Okay. So a function, right? A function takes some value x in, right? And spits something out. So I want us to look at functions. I want us to do, I'm going to put the definition of a function. So function. Hey, how's it going?
Good, how are you?
Doing good. So this is the definition of a function. The definition of a function. Now, when I write the definition, it's going to look weird, right? I'll explain it after I write it down. A function is a rule which assigns to each input x a single output f of x. That's the definition of a function. So let's try and understand what this means visually. I like to think of a function as a machine, right? That's the common way it's presented to students. Or what's happening is you're taking an x, you're plugging it into some machine, right? This is the function f. And then what comes out over here is the value of the function after you plug x in. So for this particular example that we did over here, right, this machine that we were working on here, it took 4 in, right, went through the machine and came out as a what? What did 4 come out as? 3, right? It came out as a 3, right? And then it took 0, 0 went through and came out as 5. Then it took negative 3/5 in, came out as 53/10, right? So another way that this can be drawn or visualized is this. And this is probably the one that you've seen a lot. We draw like this oval looking thing, an arrow F, and then over here another oval. So this is kind of like the x's that we plug in are the things in the first oval, and the things that come out are the second oval. So if we had, like for this particular function, this example we were looking at, when we took 4 in, right, 4 went to 3, and then 0 went to 5, and then, what was it? I just erased it. Negative 3/5 went over to 53/10, right? That is a visual representation of this machine, this function. Got it? Now let's look at the definition. A function is a rule, right? It's a rule. Now the rule we have is actually what's happening in here. It's taking half of this and then adding 5. That's the rule, okay? Whatever goes in, you take half of it, multiply it by negative, right? And then add 5. So it's some rule which assigns to each input, the input is the x, a single output, a single output. That's a critical word in this. You have to have a single output. So let me show you an example of something, and you tell me if this is a function or not. Right, so forget this example. I'm just going to give you a brand new one. Let me do it right here. So let's say we have this scenario happening. I tell you that 1 goes to 3, 2 goes to 7. So far, is that a function? For every single input, does it go to a single output? Yes? Okay. 5 also goes to 7. Now don't jump the gun here, just think about the definition. Does this thing assign to each input a single answer? I'm seeing yeses and I'm hearing no's also. So let me ask, does 1 go to one place? Yes. Does 2 go to one place? Yes. Does 5 go to one place? Yes. Every input has a single output. So this is still a function. The fact that 2 and 5 go to the same number does not matter. So this would be a function. I could call this f, all right? How about this? How about 1 goes to 3, 2 goes to 7, 5 goes to 9, and 5 also goes to 3. Seeing no's now, right? This is not a function. The reason why? Why is it not a function? Yeah, the 5, right? The 5 is the problem. 5 goes to 2 places. And this says that for every input you have to have a single output. You can't have 2 outputs. I like to think of it like a I don't know, kind of like a car wash, right? You take your car through the car wash, right? It's like you put a car in, you get a car out. Car in, car out. Car in, car out, right? Here, dirty car, clean car, right? Dirty car, clean car, dirty car, clean car. Maybe these cars look a lot the same. Maybe they're the same model, same year, right? And they come out, they look almost identical, okay? This is like taking a car and coming out with 2 clean cars. It just doesn't make sense, right? That'd be a hell of a car wash. That'd be a hell of a business, wouldn't it? Okay, all right. So you get the basic idea of a function. The rule, it's assigns to each input, single output. All right. So now what I'd like to do is take a new function, something new, and it is not going to be linear. You know, we started this by talking about a linear equation in 2 variables, and I said, oh, if you solve for y, then we can replace the y with this f of x thing. Oh yeah, I didn't tell you how to say that, sorry. The way you say that is f of x. I apologize. That's the way you say this, f of x. F of x. All right, so let me give you a new function, okay? A new example here. Let f of x, okay? I'm going to define this function for you. It's going to be negative 3x squared plus x minus 4. Now we're going to study that later on this semester. That's actually called a quadratic function, but you know, let's just deal with this one step at a time here. So I've defined a function. The reason you know it's a function, okay, the reason you know it's a function and that every input goes to exactly one output is because I put f of x. If I do that, I'm telling you, you don't need to worry about it. I already know it's a function, right? So I'm defining this to be this. So now let me ask you for a few values. What would f of 2 be? What would f of negative 1 be? And let's go f. We won't do a fraction here. You want to do a fraction? You don't want to, do you? We better do one. 2/3. Okay, parts A, B, and C. I want you to find these values. So I want to know, where do those inputs get sent to, right? Where do they get sent? So to do the 2, all we have to do is replace all the x's in here, right, with 2's. So negative 3, and then I have to square the 2, and then add the 2, and then subtract a 4. What do we do first? Order of operations. What do you do first there? Do whatever's in parentheses, but the only thing in parentheses is 2's. You can't really do anything to 2, right? So you move to exponents. So I'll square this 2 first. So that becomes 4. So I have negative 3 times 4 plus, I don't need the parentheses around the 2. I just put it there because, you know, if that was a negative, then I would have plus minus. So I just want to be careful. So that's my 2 squared, and now I do multiplication, right, before anything else. So these 2 multiply together, you get negative 12 plus 2 minus 4. And now you just work from left to right. So these 2 together give you negative 10, and then minus 4, and that gives you negative 14. You all agree with that? Any questions with that? Kind of squinting, you all right? Sure? Okay. All right, let's move to the next one. -1. Why don't you try this? Take a second to see if you can figure out what this one is. Let's see if we get the same answers. I'll give you like a minute. Start with the exponents. Is Abigail here? That's you, okay. That's what I have on my roster. By the way, I'm going off the official roster, so if you want me to call you anything different, let me know and I'll type it in here so I can, just so I know. Abigail, were you here last time? No, okay. I thought you were. That's fine. Okay. You got it. If you get it, try the next one. Yeah, if you get it, move on to the next one. See if you can get that one going. See, Allison, are you here? Allison, did you get the first one yet? Or are you still working on it? Or sorry, it's part B. Did you get that one yet? Yeah. You wanna tell me what you got? -8. Okay. Anybody disagree? Everybody agrees? Okay, it's right then. Good. All right. Anyone have questions on -8 here? On how to get it? Everyone's all right with that? Let's look at 2/3. 2/3 a little weird. We have to square 2/3 first. When you square a fraction, it means you multiply it times itself, right? And so you just multiply straight across. 2 times 2 is 4, 3 times 3 is 9. So you get 4/9. So this becomes -3 times 4/9, and then plus 2/3 minus 4. Understand? I need to multiply these two together. So you have some options here. You can look at this as -3/1. You can go straight across right now, or you can cancel, like reduce the 3. Because 3 goes into 3 once and 3 goes into 9 3 times. I like that way because it keeps things small. And now multiply across the top, you should get -4. That's -1 times 4, and then 1 times 3 on the bottom. Then plus 2/3, and then minus 4. Questions on that? And then here, we can put these two together because they have the same denominator, right? So all we do is take -4, add 2, and that gives you -2/3. And then I have to still take away 4. So I'm going to rewrite 4 as 4/1 so I can start to get another common denominator. So I multiply top and bottom by 3. And I should have here -2/3 and then minus, multiply across, 12/3. And now I can put them together. What is that going to be? -14/3, good. Okay, so for this function, right, if you send 2 through it, right, it spits out -14. If you plug in -1, it spits out -8. At least that's what you all said, yes? And then 2/3 goes through and comes out as -14/3. So that's the machine. That's what the machine is doing. So what we like to do, okay, is we like to try and visualize these machines. Like visually, understand what they look like. Just like when we had the line, remember the line just represented all these solutions to some equation? We can do the same sort of thing with functions. We can try and visualize what's happening. So for this function, let's look at this one. What I'm going to do, let's erase this, is I'm going to try and visualize what's going on here. So I'm going to draw an x and y axis, but instead of putting y here, remember we had replaced the y with f of x? I'm going to write up here f of x. And then this is going to represent my input, and this is going to be my output. So let's look at this first input. We plugged in 2, and we got negative 14, right? So the way I'm going to look at this first part, this right here, is that when I plugged in 2 went in for x, the output was negative 14. I'm going to look at this as a point on the graph, okay? The input and the output, right? The x and the y, if you want to say y. And then the next one means that when I plugged in negative 1, I got negative 8. And then the last one means when I plug in 2/3, I get negative 14 over 3. So these are all points now, right? I have 3 points. Yes? 3 points? And so what I'm going to do is I'm going to plot them on this graph. So let me plot them. So let me go with the point 2, negative 14. So 2, negative 14. I'll do it here. That means I'm going to go to the right 2 and down 14. So I'm going to count like this. I'm going to go 1, 2 to the right, and then down 14. The way I'm going to do that is I'm going to count in increments of 5 this way. Negative 5, negative 10, negative 15. So if I put this point right about there, that's the point 2, negative 14. It's not quite to negative 15. Okay? By the way, when you draw your little tick marks, right? These are called tick marks. When you draw your tick marks, if this is 1, right, you have to maintain that same, that same distance on every increment on the x-axis. But you're free to use something different for the y-axis. You just have to be consistent along the x-axis. Like I can't say that that's 1 and then 10 and then 1,000. Like that just doesn't make sense that way, right? You can't say that's 1 and then from here to here that's 9 more. It just doesn't make sense. So just maintain consistency on the x and then maintain consistency on the y. Yes? The next point is negative 1, negative 8. So I go to left 1 and down about 8. I'm just eyeballing this, okay? That's negative 1, negative 8. Now, if this was a line, right? If this was a linear equation, we'd be done, wouldn't we? Because we have 2 points, we draw a straight line. But this is not a linear equation. The way you can tell that is because we have a squared here. And that, again, we're going to study these in more detail later. But for now, let's just plot this last point. And I'm going to need you to get on your calculator if you want this to be easy. Do 2 divided by 3 on your calculator, you should get 0.6, right? 0.66666, right? So this is really like 0.666 forever, comma, and then do negative 14 divided by 3. What does that equal? Should be like negative 4.333 or something? 4.6, oh yeah, 2, yeah, 4.6666. I hope the 666 doesn't bother you. All right, so this, we're just eyeballing this. We're gonna move to the right 0.666. So this is halfway, that's 0.5. 0.6 would be a little to the right of it. And then I need to go down 4.66, so I'm gonna just, again, I'm not trying to land a man on the moon here, okay? I'm just trying to draw a picture in the classroom. So this is good enough. Over to the right, down a little bit, let's label it. This is 2/3 negative 14 over 3. Okay? Now, if I did this, if I continue to do this for a bunch of inputs, I would start to get a feel for what this thing looks like, right? Which I'm not going to do now, we'll do later. Does anyone know what this looks like if you actually get all the points together? Like what the shape is? It looks like a U. They're called parabolas. I'm not quite sure exactly where it would go, but it would probably look something like, well, hold on, I can do this pretty easily. Negative b over 2 times negative 3, so that's going to be 1/6. So it happens at 1/6. So it actually, if you were to graph this, if you were to do all the points and put all the points together, it would actually look like this. It would go up like this, and it would come back down like this. Oh shit, that's terrible. Okay, I can't erase that easily. It's going to go like this. It's going to look like a U, kind of like this shape. Okay? Don't worry about it. We'll do that later. But this is called a parabola, right? Okay. The main thing you have to understand, or the main thing I want you to understand, is that when you have a function, what this notation means, what it means to plug numbers in, how you do that, right? The mechanics of it, and then what this can mean to us visually. Got it? All right, I'm going to put another example up here. I'm going to ask you a couple of questions. While I'm putting it up here, I want to just have a quick little discussion. You know, I sit here and I think about you and your life and what's going on and, you know, why you're in college and whether or not you're sitting there going, oh my God, why do I need to know this? Why do I need to know this? My God. Okay? And I just want you to know that my perspective on this is this. None of y'all are going to be building bridges or airplanes or anything else, right? This is Math 13-14. This is not the engineering track. We've talked about that, right? So I want you to look at this more about, like, you know, what you're trying to do is demonstrate that your brain can process information in a certain manner. I mean, math is very logical. It's very step-oriented, procedure-oriented. And so don't look at it so much like, oh, why do I have to do this? I'm never going to need to do that. Think about it more as like, can your brain take sets of steps and procedures and then execute that without making little mistakes? That's what this is about. Detach yourself from the idea of the lines and the parabolas and more about, I always think about it like, if, let's say you get hired by a company, right? And they take you to the copying machine, right? That first day you're there, they're like, here's a copying machine. And they show you how to use it. And the next day, you need help again. And they show you the second time. And then the next day, you still can't figure it out, right? Well, that's probably because your brain has never really trained, you've never trained your brain to think of things in that logical, procedural manner. That's the way I look at it. Like a college degree is about you demonstrating